Let us talk about this problem. We are given an array of integers. The array may be sorted or unsorted. We need to print leaders in it. Now, what is a leader in an array? An element is called leader if there is nothing which is greater than this element on right of it. For example, in this array, 10 is a leader because all the elements on right of it are smaller than this. 4 is not a leader because 6 is an element which is greater than 4 and on right of it. 5 is also greater. So because of 6 and 5, 4 is not a leader. 3 is also not a leader because there are greater elements on right side of it. 6 is a leader because there are 2 elements on right of it and both of these elements are smaller. 5 is also a leader because there is only one element on right of it and this element is smaller. 2 is also a leader because there is nothing on right of it. So the rightmost element is always a leader. Let's see second example. We have a sorted array 10, 20, 30. In this array, if you see 10 has 2 greater elements on right side, 20 has 1 greater element on right side, 30 is the only element which does not have anything on the right side, so it's the leader. So if you have an array which is sorted in increasing order, then the last element is the only element which is leader because everything else will have a greater element on the right side. Let's now talk about this array which is sorted in decreasing order. If your array is sorted in decreasing order, then every element is leader because for every element there is nothing on right side which is greater than this element. One last thing about leaders, a leader has to be greater than all the elements on right side. So even if there is an element with same value, then this element is not considered as a leader. For example, if we add a 10 here, then this 10 is not a leader because there is an element on right which has equal value. But this 10 is a leader because all the values on right of this 10 are smaller. So our output remains same, but we see 10 only once because this 10 is not leader. Why? Because there is an element which is equal. So an element is leader when all the elements are smaller. Even not equals are not allowed for an element to be leader. Now please pause this video and try to write down a solution for this problem. We are going to talk about two solutions. One is n square and the second solution is n. Let us first talk about naive solution, which is big O of n square. And the idea is simple. We traverse through every element. For every element, we traverse on right side of it. And if we find an element which is greater or equal, we break the loop. And we say this cannot be a leader. And if we never broke the loop, then we say this is a leader. So we begin from index 0. I've written here index is. And we go till index 6. That's what we do in the outer loop. And for every index I, so say I is 0, we go on right side of it. And to traverse the right side elements, we use another loop. And j varies from 1 to 6 for I equal to 0. So j is 1 to 6. And for every element from 1 to 6, we check if array j is greater than or equal to array I. And as soon as we find an element which follows this condition, which is greater than or equal to array I, we say this element cannot be a leader. And how do we say it? We use a flag variable. We set the flag equal to true, that this cannot be a leader. And at the end, if flag remain false, if we could not find any element that was greater or equal, then we say this is a leader. We print this element as an output. That's the simple idea. So you will traverse beginning from 0 and you will break the loop. You will set the flag equal to true, so you will not print 7. Then you will come to I equal to 1. You will begin the loop j equal to 2 to 6. For 10, you will traverse through all the elements one by one. And when you come here for this 10, you will set the flag equal to true and you will break the loop. So you will not print this 10 because flag is true. You print it only when flag is false. So you will come here for I equal to 2. Again, you will find a greater element and you will break the loop and you will not print it. You will come here for I equal to 3. This time, you will check for this condition for j equal to 4 to 6. And you will see all the elements and you will see none of them go inside this if condition. Array j never becomes greater than or equal to array I. So your flag remains false. And when you come out of the loop, you print 10, right? Same thing happens for 6, same thing happens for 5, same thing happens for 2. You never find an element which is small, which is greater or equal on the right side. So your flag never becomes true and you print all these 4 elements. Let us now talk about an efficient solution to print all leaders. One disclaimer about this solution is going to print the leaders from right to left. This is going to print the last leader first, then the second last, then the third last, and then the fourth last. So for this input array, instead of printing the output as 10, 6, 5, 2, it's going to print the output as 2, 5, 6, 10. We can change this program to get the output in the order from left to right. But let us now first talk about the simple program, which is efficient and prints the leaders. So the great idea in this solution is to traverse from the right side. We know that last element is always a leader. So we initialize the last element as leader and we print it. So we print the last leader as first thing on the screen. Now what we do is we start traversing from the second last element. We run a loop for int I equal to n minus 2, I greater than equal to 0, I minus minus. Inside this loop, we simply need to check if current element is greater than current leader, then your current element is also a leader. Because you are traversing from the right side. You have the maximum element from the right side at any point. And all you need to do is you simply need to check whether the current element is greater than the maximum element from the right side. If it is greater, you print this element also as leader. So you come to 5, you see that 5 is actually greater than the current leader. So you make 5 as current leader and then you print 5 also. So you print 5 on the screen. Now you go to the next element and you check whether this is greater than current leader. This is also greater than current leader because current leader is 5 and this is 6. So you make this element as current leader and you print it. Now you come to this element and you see this element is also greater than current leader. So you print this element and you make it current leader. Now you come to this element and you see that this element is not greater than current leader, right? So you do not make it current leader and you do not print it. You keep the current leader as 10. Your current leader remains 10. Now you come here and this element is also not greater than the current leader. It's actually equal to the current leader. So you do not update the current leader, you do not print this element. Now you come here, this is also not greater than the current leader. So you do not update the current leader and you do not print it. So you get 2, 5, 6, 10 on the screen. And the idea is simple. You maintain the current leader, which is maximum from the right side. If your current element is greater than the current leader or maximum from the right side, then you make it current leader or maximum, right? And you print it. Now, how much is the time complexity of the solution? This solution is simply theta n. We are running a loop from n minus 2 to 0. So it's a theta n solution. But the drawback here is it prints the elements, the leaders from right to left. Now, if you want to print the leaders from left to right in theta n time complexity itself, how will you do it? You can simply make an array to store the leaders that you are getting, right? You can keep putting the elements in this array and then you can reverse this array and then you can print the reversed array. So you will need theta n auxiliary space, then you can print the leaders in the order from left to right. But the time complexity, it remains theta n because reversing an array is theta n operation. We have already discussed it in the reverse video.